All right, so here's the questions that really test, this is sort of like a comprehensive review of all of the terminology and all the concepts that we've talked about with regards to trig, okay? So it says, given that the tangent of some angle is negative 5/4 and the cosine value of that angle is greater than 0, meaning positive, find cosecant theta. Okay, so with all of this information, first things first, when you look at these numbers, okay, now to this point, if you've been keeping up with class, if you've been keeping up with the homework, maybe you realize that every time you're asked to find the tangent of something, we see some values showing up a lot. We see radical 3, we see radical 3/3. Sometimes we see 1, sometimes we see 0, sometimes we can't take the tangent of a value. So these are the only 5 outputs for tangent that we can come up with from using the unit circle. Clearly, negative 5/4 is not equivalent to any of these 5 values. So right then and there, that's a context clue. Let's be math detectives here. That's a clue that says we're not going to be doing this problem using the coordinates of the unit circle. So if we're not going to be using the coordinates of the unit circle, we better be using right triangles. Okay, now here's our next context clue. The cosine of this angle is greater than 0. If the cosine is greater than 0, but the tangent is negative, angles that satisfy both of these conditions can only exist in one place, right? So when we're talking about doing this trig, and do you need the coordinate plane? Not necessarily, okay? But let's talk. If I have an angle that I draw into the first quadrant, the sine values are positive and the cosine values are positive, which means the tangent values are positive, right? Over here in quadrant 2, cosine values are negative. So right away I know my angle is not terminating in quadrant 2, because over here, angles that are in this position, okay, have negative cosine values. The same rule applies down here in quadrant 3. Any angle that terminates in quadrant 3 has a negative cosine value, and because both sine and cosine are negative down here, when I do y over x, I get a positive tangent value, which doesn't fit this description. Ergo, therefore, I know that the angle in question has to terminate in quadrant 4. Okay, so the tangent of this angle, and just to be clear, the angle in question is here. Okay, this angle. This angle has a tangent value of negative 5/4. It has a cosine value that's positive because over here, our x coordinates are positive and our y coordinates are negative. So we know that it has to fall down here. And based on our conversations in class, we know that to find the tangent values or cosine values, to find the trig values of this function, we can use the reference angle. We just better make sure that our signs are right, okay? So even though theta is this angle here, I'm going to use the reference angle here. And so I'm just going to draw this just so I have something to look at. Okay, it's not going to be perfect, but if the tangent is negative 5/4, and we're not going to use the unit circle, we've already said we disqualified the unit circle by saying none of these values, right? This is not any of these. So that means we're using SOHCAHTOA. So the tangent of this angle is the opposite side over the adjacent side. Well, here's our opposite side. Here's our adjacent side. So the opposite side is 5. The adjacent side is 4. Don't forget that it's negative. So which one of these makes sense to be a negative number, right? Obviously, the 4 that's going in the positive x in the value in the direction of positive x values, that's not going to be negative. What about this distance, right? Again, should we label the side of a triangle as being negative 5? No, doesn't make any sense. You can't talk about triangle sides being negative, okay? But for the purposes of this problem, and to keep that sign in there, that not the negative sign in this problem and make sure that our values come out right, we're going to label that as negative. Okay. I'm going to, if you all don't mind, skip past the Pythagorean theorem, which you should all be very good at this point, and get the square root of 41 for our hypotenuse. Okay. Everybody okay with that? Even if this is negative, the hypotenuse will always be positive. And we were asked to find cosecant. If you're in my class, that means we're finding sine. We're going to find the sine of the angle first, then we're going to flip it over. That's how we find cosecant, right? I know there's Cho-Shikow, if you remember Cho-Shikow, okay, as the reciprocal of SOHCAHTOA, fine. But I'm of the opinion that be masters of one thing, okay, and that is the original three, the original trio of trigonometric functions. Be a master with that, right? And use that all of the time, even when you're asked to find reciprocals. So the sine of this angle now, we'll call this theta, even though it's technically theta prime, but we'll say theta. The sine of that is the opposite side, which is -5, over the hypotenuse, which is 41. Now, before you start getting all itchy and wanting to rationalize this denominator, we're going to flip it over anyway, right? So the cosecant of theta is the reciprocal of this, which is radical 41, negative radical 41 over 5. Okay, so use the context clues. Recognize this is not a number that we associate with the unit circle. Okay, we're not going to use the unit circle. We're going to use right triangle trig. Make sure when you're labeling this, if something's supposed to be negative, just make it negative, right? Just for the sake of getting this sign right when we're done. Okay.